Okay, hello and welcome to tonight's webinar on the IB with TI-nspire Statistics. My name is Stephen Julian and this webinar is sponsored by Texas Instruments on a very relevant night for this topic on the Australian Census Night. Tonight, the main focus of our presentation is we're going to be looking at different things, obviously, with the statistics, or the presenters will. It will involve many types of different statistics, both ungrouped and grouped data. They'll be looking at histograms, box plots, and different ways that the data can be represented using the TI-nspire, and also including things such as the Pearson's correlation coefficient. So many fun and relevant things, again, for a night of census using the TI-nspire. Now, in terms of our two presenters, our two wonderful presenters tonight, we have Bashina Graham, who is a teacher from Wesley College. She's a very experienced VCE specialist mathematician and very, very experienced IB high-level mathematics teacher. So first of all, good evening to you, Bashina.
Good evening, Stephen, and good evening, everyone.
So just to finish off on Bashina, she has also held roles such as the VCAA assessors for specialist maths. She's also had many other high-level positions, particularly in the IB again, including Deputy Chief Examiner. She's passionate about using technology in the classroom, and having seen many of Bashina's webinars and her presenting live, I know you'll get a lot of very useful information from her tonight. Our second presenter is Pam Durant, who's also at Wesley College. So good evening, Pam. Good evening, Pam.
Hello, Dave.
And Pam has been teaching for over 20 years, mostly at Wesley College. She has been teaching the IBDP program since 2006 and is a senior examiner for the HL Paper 2. She has also taught all senior mathematics courses within the Victoria Certificate of Education program. So two very, very experienced presenters tonight, and particularly a lot of information and wealth of knowledge in terms of the statistics program. So I believe our first presenter tonight is Bashina.
Good evening, everyone. So you can see my screen now, yes?
I think it's just coming up now.
Just coming up. So just a short introduction what we'll try to achieve in tonight's webinar. As we know, there are three courses, study, standard level and high level, and they require various levels of statistics knowledge. Studies probably is the most, and statistics and the most basic. When we go to high-level option, of course, that's the most complicated. So we'll try to start with simple things, and I will try to show some features on TI-nspire which are not that commonly used. So we'll start with some univariate data and look at the measure of center, mean, and mode. So this is the first activity, very straightforward. So we have some numbers given here, and I prepared a notes page because that is quicker to show what's happening. So, but it can be done in the calculator screen. So if I take the first list, I can store it as list 1 by going Control Store. And now, as you can see, I have approximate values here for mean and median, because whenever I find them and the calculator is in auto, they come as fractions, and that is quite annoying because you usually forget to press Control Enter. So that's one of the ways of overcoming this particular difficulty using the approximate. So that was the first list we had with mean and median. And now we have another group of people and slide the numbers, change the numbers slightly, and then we can see how this change will affect the median and the mode. So clearly the median will stay the same with list 3, I think, because now we are increasing the 12 to 20. So that's quite basic, but it shows nicely how the mean and medians are affected when now we change 20 to 50. So that's a nice activity to display it this way, and then we might have a discussion in class which measure of center is not affected by outliers and which one is. And we might have a poll question as I have designed here and some other discussion how that happened. So that was the first activity, and now the second one is I've entered 3 data sets. One is a symmetrical one I called SKU1, SKU2. So these are the data sets, and now we'll enter the graph, statistical graph, and let's say start with the symmetrical graph. Here we only have one list each, so we can now go to change to the histogram. And this data looks mainly symmetrical, but there is a noise feature on the calculator. If we go to menu and analyze and plot value, and that comes with V8 because I practice on that a bit, but we can simply enter on the histogram mean of, and you can either type symmetrical or you can get it from variables, and it will display the mean on the histogram. And we can do the same by going plot value, but this time I will do the median of symmetrical again, so it comes bold. And now I can see that those two for this data set are very close. So now if I try to do the graph, similar things for SKU1, and then plot type and go histogram, and if I repeat the whole exercise, going mean of this time, getting it from variables again, we have SKU1 here, and then getting menu, analyze, plot value, but this time I will do the median of SKU1. That will now clearly show that the mean is pulled towards the tail, towards the skewness of the graph. And that can also be done for SKU2, where I have those two values, mean and median, but this time again, mean goes towards the skewness of the graph. We can display the same thing if we change it to a box plot. So of course, box plot by itself would show the median, so we can just show the mean on the box plot as well, and then we can also identify one outlier in this data set. So then another question for the students quickly to send whether they understood. In a skewed distribution, the mean is pulled in which direction, and if the mean median are equal, the distribution is. And again, we have different types of questions, so if you want to create your polls or questions, you can do true and false, yes, no, agree, disagree, or you can have expressions, matching, and so on. So there is a lot we can do as well. So that was the first activity here. And now from here, from just numbers, we can go to something more interesting. And here I have the data which shows the model names and prices for some sport cars. So some selection here, and the students, usually boys, are quite interested in those. Now, on the next page, I just show that there is the feature which allows you to lock and unlock the price if you want to send it to the kids and everyone getting the same results and they are not playing up. So you can lock the price and then just delete this page, so they usually don't know how to lock and unlock things. So what I did here, I did the similar thing, doing the histogram first and putting our values so we can see mean and median as well. And again, we could do the same thing with the box plot, and it will clearly show some outliers. So that was the next activity here. I close this one. The third one is the data showing the heights of men and women in different countries. And This one will allow us to create two parallel box plots. So it says create parallel box plots showing men height and women height, add and outliers, identify which country has unusually tall or short people, and so on, find the mean, median, and summarize your findings. So now it's a slightly different procedure if we do the box plot and we want to have two. So the first one we do in the same way. So we change to a box plot. But now, if we want to do the next one, I press the right click on the computer, but students need to go over there and press control menu. Whatever we do on the computer with the right click is control menu, and that allows us to put another variable. So now I have women height and men height, and in this way I can see two box plots and identify the numbers which are the outliers clearly for women height, and then students go to the list and see what happens there. If I open the calculator screen, I can also go to statistics, stat calculations, one variable statistics, and if you want to display it, so you can say my list 1 is women height, my list 2 is men height, and so on, so we can get the data shown this way. And of course, the same thing can be actually achieved in the spreadsheet. So the thing with having that in the spreadsheet using the statistics has the advantage that when we change something, so we have two lists, and again we select what it is, that then you can see the changes straight away. So now if we go there, so we have one variable and that shows women height, and this one shows men height, and we can scroll down and look at the data. And also it's worth mentioning, and Pam will talk more about it, that we are using the population standard deviation, and this is required for all IB courses except for high-level option. So that is how we can do the parallel box plots, still without frequencies. Now, the next activity is, which I have written here. So that is something students can collect themselves, like the length of the songs, let's say the top popular 100 songs in iTunes, and the data can be grouped here and done with frequencies. So of course they need to get the midpoint and the frequency to be able to enter it onto the calculator. And from memory, this is the one with frequency. Students usually forget later how to do it. So we have length and frequency. So both if we want to do the statistics, and then when we want to create the box plots, we need to tell the calculator that the data actually comes with frequencies. So that's the option, add X variable with summary list. So our data is the length and the summary list is the frequency, and I can display it as the histogram or change to a box plot and get all my values. Now if I want to show the mean here, I can't do the mean of length because of course it would only do the mean of length statistics, but if we look up variable, but then I would have to do, let's say if I want to analyze plot value, and I want to show mean of, and then we can go to variables, and then we can identify X, which is actually calculated in the previous scheme. It doesn't want to do it for me now. Sometimes it happens, so we might just leave it at this stage. We can also put two screens next to each other and then play with changing some of the data and see what effect it has on the box plot if we change some of the data. The next activity is the one which is on regression, and I actually adapted the activity which is written by NASA, and it's called Spacewalk Training. And we have here NBL, which is not National Basketball League, but Neutral Buoyancy Laboratory, and they actually simulate the spacewalking for astronauts, and it's all very nicely described. I won't be going into details, but actually the file comes nicely prepared with all description here, so the students can read, and there is also a student's handout. The units are unfortunately American units, feet, and the pressure is also in PSI, but I don't think for the purpose of this exercise it doesn't matter that much. So actually it tells the students what to do. I won't be going through every single step, but basically to draw the regression line, we need to choose two variables, and this regression looks pretty good, and then analyze regression, and we put the regression line on the screen. This regression line on the screen is not that useful because it can't be used that much later. So again, either in the spreadsheet or in the calculator screen, if we do the regression in the same way, but that allows us water depth, and this saves the regression equation into equation, and let's say here it saves it in F1. So when we go to the calculator screen, to the graph screen, and you go one up, you have the regression equation on the screen, which is actually quite useful, and this equation can be later used for predictions and for using numerical solve to find the values and so on. There are some questions in this file: interpret the slope and the y-intercept as the questions which are usually asked on the exam, and testing the understanding, and then determine the correlation coefficient and interpret its value. So they give the screen here, so we need to get the calculator. Again, only one of the ways, can be done in various ways, and that comes again in the same screen as I already did, but then if we look at the regression, it is nearly perfect regression, so clearly it's very, very close. Now, originally this task had residuals, but we don't do residuals in any of the courses, so that's how I adapted that. I removed everything on residuals. And then we have a series of questions, and as I'm saying, they were referring to the residuals, whether the linear model is appropriate. We can only really go by looking at the graph and looking at the correlation coefficient. So now there are actually two data sets. One is for the scuba divers and one for the astronauts. And then they ask to do the other one, which is similar. So I will leave it. So for the second data set, and then they also ask to draw two parallel things. So we can again put the first one here, and then we can do the one, and then if we press here and add weight variable, I can add another one on the same screen, and there is a nice discussion what's the difference, and it actually says in the description of the whole laboratory and so on that the astronauts' suits are pressurized, and that's because that will make them feel the weightlessness more, like feeling like they are in space. So that's the reason. Now, one more thing that talks about the transformation, which will be this vertical translation. Again, we don't talk that much about transformations in IB courses. Now, one more thing, so there are some predictions, so that ends here. but in the studies course, we already have our function here, f1, that disappeared from my screen. I'll go back, and what I actually want to show, I might go to this screen. So often in the studies course, the students are asked to find the mean value for the independent variable, the mean value for the dependent variable, and plot it on their graph. And they very often do it by hand, but that can be done nicely using the calculator screen here. So using the graph screen here, so the ways of constructing this, if we go to the graph screen, we need to change the graph entry to the scatterplot, and then we put the water depth as list X, and let's say we'll do, that only allows me to do one of those. Okay, we can do it here because it has different problems. And I can't see anything, so I try to go window and zoom data feed. So now what I achieved here, I have the scatter plot, and if I have the scatter plot, now I can also go graph entry, and that allows me, using the equation, draw the vertical line, and I might draw the mean of variables, and I have this here. That doesn't want to do it. That always happens in the thing. So the other thing, we can get the thing that I didn't do statistics on this one. I did V1. I might just go to the final one. It does work here, but of course something didn't quite work at this point, but that is the idea using the scatter plot. So the last activity I have here is using chi-squared for independence and the hypothesis testing. So I selected some data here which actually shows the level of education and the level of income for some feminists, which was tested, and we want to answer the question whether highest levels of schooling attained is dependent or independent of parents' wealth, and that's how we set the null hypothesis here. So what we need to do, we need to enter the data into the matrix, and then we call it the observed matrix. And then to perform the chi-squared analysis, we go to maths. Now I'm in the notes page, so it shows it on my screen slightly different. And then we go to start test and choose the right one. That wasn't the right one because we only need to have one data, so we do start test and we go to weight test, and then we put the observed matrix. And the calculator comes back with our chi-squared value and with p value, and we assume that we are testing at 5% significance level, so we compare the values that our value is higher than the critical value. So how can we get the critical value? We look at going to menu, and we have inverse chi-squared, which gives the area and the degrees of freedom. It's not required for the exam, but it is very handy for the students to know how to do it for their project. So they can find the inverse chi-squared value using the significance level and degrees of freedom, and then they compare the statistics obtained on the calculator here to the critical value, or they can compare the probability which the calculator gives to 5%. So the probability is less, so that's one reason to reject the null hypothesis, and the other reason to reject is by looking at the chi-squared value being greater than the value which is the critical value for this particular situation. Pam will talk more about standard deviation, but there is a noise activity which I just came across, and it is on Australian website, and this one says some levels here like 9, 10, 11. I actually did that with my studies class again, and that was about firstly talking about how we calculate standard deviation by hand, even though they don't need to do it but by hand, but this is quite nice if they do, because they understand what's happening. So firstly we look at, and this is also a nice topic because this is about cricket, so very popular in Australia. So we look at the mean values first, and then we calculate the deviations from mean values, and there are some questions whether it's a good approach to look at the measures of spread, and then we go to standard deviation squared and so on. So the students actually experience doing those things themselves, so they see what happens. And then there is a series of questions, and there are also full answers in the teacher's worksheet. And there is some extension here depending how far we want to take it. And it is looking what happens if we actually change the data by adding the scores or by multiplying the scores, what happens to mean and standard deviation. So this is quite a nice activity to use with your students. So thank you very much. That's all I had to show, and Pam will take it further. Thank you.
Hello everyone. Hopefully you can all hear me now. So I'm going to look at a few things, just not quite as sophisticated as Virginia, but some of the things, how do you get to the various menus that you might like to use. So as Virginia said, one of the things that I've found over the past years is that the kids really don't have much of an idea about why we have standard deviation as a measure of spread and why we need a measure of spread. So I start with a very simple data set here. In fact, I've got 3 data sets, all 10s. They're all centred around 10, so all 10s, 8, 9, 10, 11, 12, and 0, 5, 10, 15, and 20. So immediately the students can see that the median is 10 and the mean is also 10. So, you know, you can have the conversation, well, if they have the same measures of centre, then surely they're the same distributions, but of course they're not. So how do we describe the differences? So one of the things I get them to do is just pop those first 5 values into a list. I like to call it something fairly simple, so data. And within the list here, I'm going to do, as Virginia's shown, using the stat calculations, the one variable statistics. I've only got the one list, and it comes through the drop-down screen here. I can see my list as data. It's going to put the results into column C. So I get my data over here, and I can see immediately that my mean is in fact 10, and I can work down. And I said there are these 2 standard deviation calculations. Both, of course, are 0 because there is no deviation in the sets of data, and we can scroll right through the list. Some of these things, in particular these values down here, are quite useful as part of the HL option on probability and statistics. But for the moment, we'll just focus back up here. So this is a nice simple data set that we can work with, and you'll notice that as I change the data to the other, you see on the right, the values are already changing to reflect that I've now got a new set of data in here. So my mean is still 10, but now there's been a change here to the standard deviation values. As Virginia said, for studies, standard level and high level core, we only use this calculation here as our standard deviation. So what the assumption is that the data that we have is a population in itself. So it's an entire data set. It's not a random sample. So the one up here is the random sample calculation. So we can see that we've got a different value here, and that's because as we go back through, of course, one of our data values was in fact the mean, two data values are within 1 unit of the mean, and two data values are within 2 units of the mean. So we get that there, and we can see that if we change those values a bit more dramatically to that we get an immediate impact on that standard deviation. So that's one of the really neat features of the TInspire, and it's something that the 84 didn't do, was actually alter the values as you change the data set. You would have to do the calculation all over again. So as I said, standard deviation is a measure of dispersion, and we have the two calculations. The difference comes from the assumption of whether or not the data is from a population or a sample. So sigma is our population parameter, and S is our sample statistic. So we, for high level core, standard level and for studies, we only use sigma, but for high level option, the standard deviation is the S value, the sample standard deviation. The difference being comes from the actual how we calculate it, and it all comes from the variance formula, because the mathematics for statistics is actually done predominantly on variance, and then we take the square root of that to talk about our standard deviation. But with the population, we only divide by the number of values in the data set. For the sample standard deviation, we actually divide by 1 less than that. So apart from when the data values are identical, like my very first one, for all other ones, we find that the sample standard deviation is a little bit bigger than the population standard deviation, and this is what's known as our unbiased estimate. So in the high-level option formula booklet, that will be denoted as Sn-1. So for the high-level option, the unbiased estimates of mean and standard deviation are X bar and Sx, as you'll see in the calculator list. That represents Sn-1. Okay, so one of the things that has come up quite a bit, and I found this with my students this year with their exploration. I have a standard level class this year. Many of them wanted to do some regression. So the first type of thing that is part of the core for all of them is linear regression. So this is the least squares regression line, and we use the Pearson's correlation coefficient that comes with that. Basically, the least squares is talking about the sum of the squares of the residuals on the regression line. So I have here a set of data of heights and weights of 11 people. So you can just scroll through the data at your leisure at some stage. And I've entered that into a spreadsheet as height and weight. And we're going to do a bit of a look at that. So I've got the data here ready to go. I'm going to do height as the explanatory or independent variable, and weight as the response or dependent variable. And we can see that it is scatterplot, but there seems to be a linear relationship amongst those. So what we can do is actually try and, let me go here, no, not there, we go to Analyze Graph. I'm going to add a movable line. So this would be something I do when I introduce statistics. And on that movable line, so I can obviously move it, I can show the residual squares. So this is a bit busy, but you can see that each data point is created a square around from the line to the data point and a square from that. So what we can see is there's a sum of squares there of 199.99, and by moving the data, the line, I can see that that sum of squares is getting larger or smaller depending on how I do it. So the kids can do this as a little activity and try and make that the smallest they possibly can. That was pretty much good where I started. Oh, I don't think I'm going to get much better than that for the moment. So what we can see there is that, you know, that's the best position at this stage for the, and I can hide those back again, move the movable line. So they can have a go at trying to fit a least squares regression line. But of course we can actually show the regression line, and you can use either of these. Those of you that also teach VCE further maths will know that we like to use A plus BX, but for IB we tend to use MX plus B. And you can see there is the actual least squares regression line, and we can also, in the menu Analyze, we can show the residuals. So you can show the residual squares, but you can show a residual plot, and that will pop up down below. So Control Z will undo your last action, so I'll just get rid of that. Okay, so once we've got our regression line, I actually like to do the regression calculations not in the spreadsheet page, but in a calculate page, because as Virginia showed, it does save it to a function, and that can be really useful. So at this stage I had height as my explanatory variable, weight as my response variable, and I can see that it's going to save to F1, and what I can see there is my R value is strong at 0.85, it's positive, it's linear, etc. So I've got a nice value of my R value. But from that, because it has been saved, and if you go back up and just click over here, you can have a look, and in case you forget where you've saved it to, it does tell you that you're saved in F1. So from that, I can then make some predictions. So if I want to find the weight of someone who is 175 centimetres tall, I find out that they are probably 66.95 kilograms. Likewise, if I do 195, that would be 84.3 kilograms. But we could then talk about the reliability of those, and if we go back to have a look at our data set, we see that 175 is within the data set, but 195 is not. So the first calculation would be considered reliable because of its interpolation, but the second one not as reliable. Within the HL option, we not only do a regression line, which that regression line that I just did would be called the Y on X regression line, but you're also required to be able to do the X on Y regression line. Both of them are very easy to do, as I just showed with the calculator. The Y on X is when X is assumed to be known with perfect accuracy, so X is the controlled variable. If Y is the controlled variable, then we would use the X on Y. So I'll just go back because it's the understanding behind it is quite complicated to go through in this little webinar, but the doing is in fact very easy. So with the stat calculations again, the linear regression, it's actually just a matter of swapping the order in which you enter the data list into your calculator, and that is the X on Y regression line with a gradient of 0.833 and a Y-intercept of 118.72. So if you go to the line here, you can do as Virginia showed before and actually use that, analyse and plot the value and show the mean of the data set, and you can do the mean of the height and the mean of the weight, and whether you do the Y on X or the X on Y, you'll find that they both pass through X bar, Y bar. I'll just escape out of that. So it's actually a very simple process to do the X on Y linear regression. So regression's not just limited to linear data sets. We can do many different types of regression, as if you just have a quick look. Oh, I'm in the wrong screen, sorry. I'll just go back a couple. If I go back here and just pop up the stat calculate, sorry, too quick, the stat calculations, you can see that there is a huge list of regressions available, and what I want to have a look at the moment are a couple that you may have used. So if I just move across. So one of the ones that is a really common regression is the sinusoidal functions. So things like tides and weather patterns and temperatures and things all lend themselves to those sorts of sinusoidal functions. But with the experience of my students doing their explorations, many of them used exponential, logarithmic or power functions as a way to model some data. So one of the data sets that's a really neat data set that's quite nice is the body mass index portfolio task from a few years ago. I know they're hard to come by, the old portfolio tasks. So I have included this PowerPoint for you which has the data, so you can download that. So if I just click on to the actual ones, you can see that there are some ages and years and their body mass. And this is actually a student that did this data portfolio quite a few years ago now, but I've just done some little screen captures to put in here. So they put the data in, and you can see that there's definitely some curvature to it, so it wouldn't be appropriate to do linear. So the possible things that the student discussed was perhaps it could be quartic, perhaps it could be cubic, perhaps it could be sinusoidal. So working with that, I've put the data into the TInspire file for you, so you can click on that. And if we go here and click, so we've got their age. I do always like watching this. The best part of statistics is getting these screens up and moving the dots. So we have here the data set, and if we want to do some regression, we can do it within the screen. So analyse regression, and you can do it here. So, you know, first go, they might try a quadratic. Well, that doesn't look like it fits very well. So we could try some others. So you could try the cubic graph, and we can see that certainly looks a lot better. You notice that the quadratic is still sitting there even though its function is not shown. But we could then have a look at the quartic, and we can see that looks much better. But there's an interesting thing with the quartic, which we'll get to in a moment, and of course the other one that they might like to use is the sinusoidal. So in each case we can see perhaps better fits to the graph. So as I said, there are a couple of things that with those, that the quadratic obviously wasn't particularly good, but if we go to the quartic regression, the age and the BMI, it actually looked like it fit very well, But when you look at the coefficients of what actually is the coefficient of the A on the x to the 4, it's a really tiny number which brings into question as to whether it's a quartic at all. Would it be best suited as a cubic? And you'll notice that when you do other regressions other than linear, you no longer have the Pearson's correlation coefficient of little r, but we have this capital R squared, which is a goodness of fit for the data point. So it's like an error measurement. And once again, the closer it is to either positive or negative 1, the better the fit. So we can do the sinusoidal regression there, and in this case we don't get an R squared measure. So if the students do in an exploration go off and do a sinusoidal regression, then they will have to do some measurement of some sort to work out whether or not it was a good fit for the data. All right, so what I'd like to do now is go through just a few of the menus that are useful for the statistics and probability option. The first part being the confidence interval. So this will be working with well, there are two confidence intervals. One works with the Z distribution, one with the T. So the Z being the standard normal and the T distribution being the student distribution, as it's sometimes known. So we use the Z distribution when the population standard deviation is known, and we use the T distribution when it is not, when we have to estimate it with our unbiased estimator, as I mentioned before. So I've got here an example of the mass of fish in a pond, so a typical type exam question that comes up. So we've got a standard deviation of 210 grams, the average mass of 64 fish, so we know how many are in the sample, is found to be 1,072 grams, determine a 90% confidence interval. One of the things that would be asked in this type of question is, you know, what assumptions do you have to make? And one of them would be that we'd have to assume we can use the central limit theorem because we're not told that the fish were normally distributed, but so that would be an assumption we would make. So doing the confidence interval, once again it's in stats, but if you have a look down to here, number 6, confidence intervals, and there's actually quite a few. We don't use as many as we did prior to the change in the course of the last couple of years, so that's a good thing, but we're going to use the Z interval. And there are two ways you can enter information, either from data or from statistics. Data actually means that you're going to use a list in your spreadsheet. We're not going to do that. We're going to use statistics in this case. And up comes a very simple menu to use. You can see it's talking about the population standard deviation, which we were told was 210 in the question. The sample mean, which we measured as 1,072, and how many are in the sample was 64. Then comes the confidence level. The standard drop-down box will always be a 95% confidence level, so we just need to change that to 90. And up comes the values. So we can see that the 90% confidence interval is between 1,028.8 and 1,115.2 approximately. So this is not the probability that the population mean lies between these two values being 0.9. The idea of the confidence interval is that if you took many samples, 90% of the samples you take will contain the population mean in this interval. Okay, so just to show you the difference, the T interval and the Z interval. I'll do a T interval 1 this time with some data to show the difference there. So I've got a sample, very small sample because I wanted to make it fairly simple for tonight, a sample of 5 numbers and drawn from a normal distribution, so we don't have to assume that. Determine a 90% confidence interval for the mean of the population. So the first thing I need to do is enter my data. I do like to call it data or sample or something simple, so I'll call this one sample. And my values were 3, 5, 5, 8 and 10. And I can work here on the screen if I'd like, or I can go to a calculate page, but I'll just do the calculation here. So if I go statistics and it's confidence interval, it's a T interval, and I am using data. So it asks me what list I'd like to use, and I can just use the click down here for sample, and the frequency, the frequency is 1 and the confidence level was 90%. So I get my lower and upper values, but more than that, it actually tells me a bit more information about that data set because it tells me the mean, the sample mean, tells me the degrees of freedom because there were 5 units in my sample, the degrees of freedom being 1 less than that, and it tells me my unbiased estimate of the population standard deviation. So we've got all that information there. The ME is a margin of error. We don't tend to do much with that. So the other thing with the confidence interval and how it links to hypothesis testing, and that is that the significance level for two-tailed testing and the confidence interval are directly linked, that the critical region is outside the confidence interval. So I've just drawn a little normal PDF here, and I've greyed out the 2 critical regions. So the confidence interval is between here, and the critical regions, the significance testing, is the extremities. And we can then do a t-test or a z-test as before. So with our hypothesis testing, we always need to have our null hypothesis. In this case, I'm saying that the data came from the sample came from a population with a mean of 9.2. My null hypothesis can then either be one-tailed or two-tailed. I'm doing a two-tailed this time, but you can do either with the calculator. If I have 25 pieces of data of which I know the sample mean is 9.8 and the unbiased estimate is 1.6, I can then do a calculation. Let's go to another screen. So menu, statistics, and so this is in the stat test menu. Because I don't know the population standard deviation, I'll do the t-test, and I've got statistics to enter. So you can see the screen comes down ready for the hypothesis test. So my mean was 9.2. My sample mean was 9.8. My unbiased estimate of the standard deviation was 1.6, and there were 25 pieces of data. I can then have a look here and change this to either one-tailed or two-tailed in either the one-tailed in either direction. I want to do the two-tailed, so I'll go with that. So once again, we get this p-value like Virginia showed with the chi-squared, and because it's 0.073 and I was testing at the 5%, that is greater than 0.05, so therefore I would accept H0. You can see my degrees of freedom is 24, etc. But I could also have got that in a different way with the confidence interval. So if I'd gone to statistics and confidence intervals and the t-interval with the statistics, and I put in my 9.8, my 1.6, my 25, and it was at the 5% significance level, so I'll do the 0.95. What this tells me is actually the critical values of my t-value, so that's quite nice, that my critical values are between 9.14 and 10.46, and because my original population mean was 9.2, it falls within those two values, therefore I accept H0. So the confidence interval and the significance level are directly linked. With the two-tailed, you can use the confidence interval and it will give you those boundary t-values, the test statistic, those are those there. But if you're doing one-tailed, then you just need to adjust your confidence level so that the values outside give you double what you are doing for the test statistic. Okay, well I think that's about it from me. Hopefully you'll all have fun now contributing to the census tonight, and I look forward to talking with you another time.
Okay, thank you to Pam and Bashina. I believe I had some problems with earlier in the session with my screen being shared, so let's see if we can get it right this time. So just bear with me for a minute. Okay, hopefully people can see my screen now. I might just check with our panellists and just make sure they can see my screen. So
yes,
Bashina, yeah, okay, yep. Thank you for that. As I said, I apologise about earlier. Okay, just to wrap up, again, thank you to Bashina and Pam for a very informative session, and again, very relevant for a night of census doing, so hopefully everyone's now highly motivated for not only using the TI, but also to get the census done tonight, if you haven't already done so. Just to go through a couple of things just to finish up on our webinar. First of all, at the end of this session, there will be a survey that will be sent to you or will come up. Please take the time to fill that out, because obviously your feedback will be looked at and will be valued in terms of trying to improve and make things relevant to what you want as a viewer. Also, an email will be delivered within 48 hours of the conclusion of this webinar with additional links with any of the files that have just been viewed. It will also, as I mentioned at the start, but you might have not seen, the webinar certificate will also be available for you. Just a couple other quick things. We've obviously got products and services that are available through the Teacher Centre and on the TI website, so you can see the address at the bottom there, I hope. And again, there's a lot of great resources available for use not only with statistics, but across all age groups and different types of students. We also have the Australian Curriculum Inspired site, which again gives you a lot of Australian curriculum linked type files, so things that can be used for Year 7, 8, 9 and 10 and the 10A course. We have, again, a lot of activities within those that are delivered not only for Victoria, but West Australia, where I'm at, Queensland and so on. There's a lot of free tests available, a lot of other products. Probably one of the ones I want to really highlight here again is the YouTube channel. So take your time to go there. A lot of how-to sites, how to use different things with the TI and the different types of calculators. We also have a Learn, Energise and Connect section. Again, really worthwhile for future upcoming information for teachers. And finally, any questions that you might have, you're more than welcome to phone the two phone numbers that are appearing on the screen right now. And if you are interested in upcoming webinars, please check out the TI website. Again, there's another webinar coming up next week, and a lot of other useful information that will be coming through to you. So I'd like to just take this opportunity one more time to thank our two wonderful presenters, Bashina and Pam. So thank you, ladies.
Thank you.
Our pleasure.
And thank you to everyone for listening in tonight. And again, I invite you to join us again when we have our next webinar. So to everyone, have a great night. Thank you.